Okay, so today we're going to be starting nomenclature. Before we get started with nomenclature, I just want to review some different things on the periodic table. So if you remember, the elements in the periodic table are found in periods, and remember there's 7 periods, and remember these two, the lanthanide and actinide series at the bottom are parts of period 6 and period 7, and there are 18 groups on the periodic table. So if you also remember, elements are separated into metals, nonmetals, and metalloids. And remembering this will be important as we name compounds and write formulas. So the metals on the periodic table are to the left of the staircase. And if you don't have these labeled already, I would recommend you do so. And the nonmetals are to the right of the staircase. And now, something we really haven't emphasized too much are the metalloids, and those lie along the staircase and are highlighted in blue on this slide. So you may want to just highlight those on your periodic table. Just remember where the metalloids are and which elements are metalloids. Now, if you notice here, aluminum is not a metalloid because it is a metal. So that's the only one besides polonium, which we won't be dealing with too much, that is along that staircase, which is not a metalloid. So compounds, when writing compounds, we're going to be writing chemical formulas. So I want to go over the first type of chemical formula that we'll be using. So first type are empirical formulas. This just tells you the ratio of elements in the compound. So subscripts below the element tell you the ratio. So if you look here, we have magnesium chloride. Chlorine has a subscript of 2, which means that there's a ratio of 2 chlorine atoms for every magnesium atom. So the empirical formulas will always be the lowest whole number ratio. And the type of compound we're going to go over first and how to write formulas for are ionic compounds, and these have positively charged ions as well as negatively charged ions. And these are made up of metals and nonmetals. So recognizing where the metals are in your periodic table and where the nonmetals is going to be an important facet of recognizing when you have an ionic compound. So, and if you remember also, ions are atoms that have a charge because they've gained or lost electrons. So remember too that cations are typically metals. These are going to be positive. And the anions are typically nonmetal, and they're going to be negative. So this is very important, remember, for your ionic compounds. So these positive and negative ions, these cations and anions, are attracted to each other because of their opposite charges. And this is just a silly cartoon. I'm just kind of showing you that attraction. Molecular compounds, on the other hand, are composed of molecules, and these almost always contain nonmetals. So these are just 2 examples, and we're not going to go over molecular compounds today, but just remember, ionic compounds of metals and nonmetals, molecular compounds that have only nonmetals. Okay, the type of naming we're going to go over today is binary compounds. We will go over ternary compounds next class. But binary compounds only have 2 types of elements, as opposed to ternary compounds, which have more than 2 types of elements. Okay, so today we're going to be working on binary ionic compounds where you have a fixed oxidation number. And this just means you have an element which only has one common charge. Okay, so when we have these kinds of compounds, we're going to name the metal just like it's named on the periodic table. And then the nonmetals ending is going to change to IDE. So an example here is sodium chloride. Sodium is the metal. We don't do anything with its name. We write it just as it is on the periodic table. But chlorine, the ending there is changed to IDE. Calcium sulfide, again, calcium is the metal. We don't do anything to its name. Sulfur, we change the ending to IDE. And the last one is aluminum iodide. So again, you notice that the metal's name stays the same. The non-metal ending changes to IDE. And we're going to go over which letters to drop for the non-metal's name, which letters you drop and then add IDE. Okay, so another important thing to remember are the charges, the common charges on your periodic table. So when we're talking about a fixed oxidation number, a fixed charge, these are the ones we're going to be using. Is that +1, +2, and then -3, -2, -1, and 0. And then if you notice here in the middle, I want you to label these. We have silver with a +1 charge, and we have zinc with a +2 charge, and cadmium with a +2, and I'm just going to add one more, which is gold. So let me just write that in here, Au, which will also be +1. Now you also notice that here we have aluminum, which has a +3 charge. So those are just important to remember, those common charges. Okay, so again, this is just another representation of the same thing, but you notice here these are the charges we'll be using for ionic compounds. Now here, I want to show you the endings, which letters we drop, and I have something which I want you to copy down, is when we look at our carbon, sulfur, silicon, and arsenic, we're going to be dropping the last two letters of those names and adding IDE to make carbide, sulfide, silicide, and arsenide. For fluorine, chlorine, bromine, iodine, and selenium, we drop the last three letters to make fluoride, chloride, bromide, iodide, and selenide. For the hydrogen, nitrogen, oxygen, and phosphorus, we drop the last four letters to make hydride, nitride, oxide, and phosphide. So this is something you probably want to write down maybe on your periodic table so you can have that handy when you're writing names until this becomes more natural to you. Okay, so I want to show you also how to write formulas for ionic compounds. So those are kind of how to write names. Now we're going to go over how to write formulas, and then we're going to practice both. So when we write formulas, we write the symbol for each of the elements, and we write the charge next to it using our common charges from a periodic table. And a lot of times students find it easy to do the crisscross method. So here we have sodium with a +1, oxygen with a -2. We bring those over to the opposite element, and those become the subscripts. So here, this would become Na2O. The important thing here, though, is you have to remember to always simplify if you do not have the lowest whole number ratio of subscripts. But here we have 2 to 1. We can't simplify that anymore, so that's our formula. Okay. And so like I said, the dangers of this is you have to be careful when you have ones that do not simplify to the lowest whole number ratio. So here we have magnesium oxide. We do the crisscross. This becomes Mg2O2, but that's not correct. We have to simplify that to MgO. So always simplify when you're done. Okay, so Actually, instead of practicing on this, I'm going to stop this for a minute and I'm going to bring up your homework and we're going to look at some problems on your homework just to practice this. Okay, so let's practice writing formulas for ionic compounds when we have fixed charges. So on the left-hand side of this sheet, you're going to be writing the formulas. So let's do some of those. And on the right-hand side of the sheet, you're going to be writing the names, and we'll do some of those. So when you're writing the formulas on the left-hand side, what I want you to do until you get the hang of this is to first write down the symbols and write down the charges that you have written, hopefully, on your periodic table. So we know cesium is in group 1. Everything in group 1 is going to be +1. Oxygen is in group 16. Everything in group 16 is -2. We do the crisscross method. Bring those over. The absolute value of those will become the subscripts on the opposite element. So this will become CS2O. Now, if these were not a lowest whole number ratio, we would have to simplify that. Let's go down and do another one. And you notice here, I do not write a 1, and 1 is understood. So let's do another one. We have calcium phosphide. We have Ca +2 because it's in group 2. Phosphorus is in group 15, so that's 3 minus. Do the crisscross. We write Ca3P2 is our formula. Again, these are the lowest whole number ratio, so we don't simplify it. And we see. Okay, let's go down and do cadmium sulfide. Cadmium, remember, is in the middle of our periodic table. It's one of the ones with a fixed charge. It's right near zinc, so CD is going to be +2. Sulfur is in group 16. That's -2. We do the crisscross. We CDS. This and this would be 2 for each. These will simplify. Our final formula is CDS. Okay, now let's look on the other side. So let's do a few of these. Okay, so for this side, we're going to write the name of the metal first. We don't do anything to the name. The nonmetal, the ending changes to IDE. And if you remember chlorine, we drop the last 3 letters of that. So we do chlor. And then we drop the I and E, and then we add to that IDE, magnesium chloride. With the next one, we don't do anything with aluminum's name. That's just aluminum. We take oxygen's name. With oxygen, we drop the last 4 letters. So actually, we drop the Y also. And then we add IDE. Okay, so guys, I want you to try all of these just to get the hang of it. Make sure that you are looking closely at your periodic table, that you're checking for spelling. And then we're going to be going over ionic compounds where we do not have fixed charges.